Hello students and welcome to another video lecture on logic design. In this video, we continue learning about Hamming code. As you know, Hamming code is a block code that is capable of correcting a single bit error. It was developed by an American mathematician, Richard Hamming. There are two parts to working with Hamming code. The first part involves encoding a message using Hamming code, and the second part involves decoding a message using Hamming code. In this video, we will try to understand the second part, that is, decoding a message using Hamming code. Recollect from a previous video the encoding of a message or data bits using Hamming code. We had taken an example of data bits 10110, and after solving this for odd parity, we got the Hamming code as 100111001. This is the transmitter, and at the other end of the communication channel we have a receiver. Now the transmitter uses the encoding technique of Hamming code that we saw in the previous slide to create the data to be sent to the receiver. The code she has prepared as seen from the previous slide is 100111001. Now this code is sent to the receiver and it is received by the receiver. Now here there can be two possibilities. The code can be received correctly or the code can be received incorrectly. Let us assume that the code has been received incorrectly. So instead of receiving 100111001, the receiver gets the data as 100110001. Clearly note that one bit has changed from 1 to 0. I have highlighted this bit in red. Now let us see how the receiver can decode this to find and correct the error. So the receiver will now decode the Hamming code to check for errors in the data which is received as 100110001. Obviously, before communication of any data, both transmitter and receiver have to agree upon the parity system to follow. In this case, recollect that we have used odd parity for encoding the code word. So the steps we follow are pretty much the same. Start with step 1, that is calculate the number of parity bits. In this process, we do a little reverse engineering here to get the number of parity bits. We know that the total number of bits that we have received is 9, since m plus p is equal to 9. We have to find the value of p, or the number of parity bits. We also know that this should satisfy the equation 2 raised to p should be greater than equal to m plus p plus 1. So if we take p as 4, we get 2 raised to 4 is greater than equal to 9 plus 1. Therefore, we can conclude that the number of parity bits are 4. Let's continue to step 2. Step 2 is the placement of parity bits. We know that the total number of bits which has been received by the receiver is 9. We also know that parity bits are placed at positions having powers of 2. So if this is the word that we have received, we number the bits starting from the rightmost bit as 1 to 9. We know that P1 is at position 1, P2 is at position 2, P4 is at position 4, and P8, which is the last parity bit, is at position 8. Since 1, 2, 4 and 8 are all powers of 2. For clarity, I have highlighted these parity bits in a red circle. Moving on to step 3. Here we check for the assignment of parity bits. we use the same code that we have got from step 2, where you can clearly see the data bits and the parity bits. Each parity bit will check those data bits whose binary code has 1 in the same bit position. So to do this, we need to assign binary codes to each bit. Now, P1 has 1 in the first bit position. So it will check for data bits D3, D5, D7 and D9. P2 has 1 in the second bit position. So it will check for data bits D3, D6 and D7. P4 has 1 in the third bit position. So it will check for data bits D5, D6 and D7. Finally, P8 has 1 in the fourth bit position. So it will check for data bits D9. Now let us go ahead and put the values for D3, D5, D7 and D9. Also, put the value for P1 that we have got in the code. Notice that P1 is equal to 1. Now, for odd parity, check if P1 is correct. Obviously, P1 is correct since the total number of ones in the code word along with the parity bit is 3. Therefore, for odd parity, P1 is correct. Let's do the same thing for P2. Put the values for D3, D6 and D7. Also put in the received value of P2. It has been got as 0. Now check for odd parity if P2 is correct. Clearly, you can make out that the total number of ones in that code word is odd. Therefore, P2 is correct. Do the same thing for P4. Put the values for D5, D6 and D7. Also put in the value for P4 which is received and got as 0. Now for odd parity, check if P4 is correct. Notice clearly in this case that P4 is incorrect since the total number of ones is not odd but even. Therefore, we note that P4 is incorrect. Lastly, put the values for D9. Also put in the values for P8 which is received as 0. Check if P8 is correct for odd parity. For odd parity, P8 is correct. Now we take this information that we got and for clarity I have listed it on a new slide. P1 is received correctly. P2 is also received correctly. And P8 is also received correctly. However, P4 was received incorrectly. So Hamming code procedure tells us to make an error word for each parity bit. Start with P8 followed by P4, P2 and P1. Since P8 is received correctly, we set the error bit to 0. Since P4 is received incorrectly, we set the error bit to 1. Since P2 is received correctly, we set the error bit to 0. And finally, since P1 is received correctly, set the error bit to 0. In other words, if the parity bit is correct, we set the error bit as 0. If it is received incorrectly, we set it as 1. Now carefully observe this error code. It reads as 0100, which when converted to decimal gives us the value of 4. Recollect that the transmitter sent the following code 100111001. The receiver, however, got it as 100110001. So as per the error word, check the bit in position 4. This is the bit which had got changed to 0 during transmission. Hence, we can clearly see that Hamming code is capable of detecting a single bit error in the code. In order to correct this, all the receiver has to do is complement the bit in the 4th position to get the correct answer. That's all for now. Stay tuned to the classroom for another video